Are you struggling to pass large complex arrays from Python to C++? You're not alone. This is a common challenge for many developers. Today, we're going to explore the best options for transferring those arrays smoothly. I totally get it. It can be incredibly frustrating when your code is slowed down by inefficient data transfer methods. Many developers have faced this issue, and it can feel like you're stuck in a loop of trial and error. Let's dive into the specific question at hand. One user, Ben, shared his experience of trying to pass large arrays of complex numbers from Python to C++. He mentioned that he resorted to saving gigantic text files, which is effective but not elegant. He wants to know if there are better options available. So what are the challenges here? Transferring large arrays can be tricky due to differences in data handling between Python and C++. We need a method that is both efficient and easy to implement. Stick around. By the end of this video, you'll have a solid understanding of the best methods to transfer your data, and I promise you'll feel more confident tackling this issue. To begin transferring large arrays of complex numbers from Python to C++, the user should consider using the NumPy library in Python. This library allows for efficient handling of large arrays. Next, the user can save the NumPy array to a binary file using the built-in function. This method is efficient and preserves the data structure. Now in C++, the user can read the binary file using the appropriate libraries. The recommended approach is to use the eigen library, which supports complex numbers and matrix operations. Finally, the user should ensure that the data types match between Python and C++. In Python, the array is of type complex 1E8, while in C++, it should be of type std complex double. Fun fact, did you know that the first computer to use arrays was built in the 1950s? It was a huge leap forward, but I bet they didn't have to deal with complex numbers like we do today. Now, let's look at the answers provided by other users. An alternative approach involves using the native Python C API along with the NumPy C extension. This user prefers this method over C types and Boost due to its simplicity and effectiveness. They provide a C++ function that integrates a 3D NumPy array of real or complex numbers, which can be called directly from Python. The user highlights that the documentation for both APIs is extensive, but manageable after a few successful attempts. They provide a code snippet that shows how to define the function and compile it using a setup script, making it easy to integrate with Python. That's it for that response. Let's explore another one. An alternative approach suggests using NumPy for efficient array handling in Python. This user emphasizes that NumPy leverages compiled code for performance, making it a better choice for large complex arrays. To access Python data in C++, the user recommends using boost.python. They provide a code snippet showing how to define a function that accepts a NumPy array and how to set up the module for compilation. Here's a pro tip. Always choose a method that fits your project's needs. If you're working with massive datasets, HDF5 might be your best bet, but for simpler tasks, NumPy could be just what you need. And there you have it. You now have several options for transferring large complex arrays from Python to C++. Remember, the right choice can save you time and headaches. If you found this video helpful, don't forget to subscribe for more tips and tricks.